Hello, I'm Ryan Johnson, and I'm with the Thermodynamics Project.
I'm Ben Lee, and I'm also with the Thermodynamics Project.
And I'm Peter Bocage, and I'm also on the Thermodynamics Project. Our project is basically proving the ideal gas law, which states a basic relationship between pressure, volume, temperature, and number of particles in a container. We prove it using classical mechanics and motion by simulating the actual particles bouncing around and creating pressure on the walls.
We've created lots of video of this. It's actually pretty cool to watch the particles bounce around, and you can actually see how everything works.
Well, my biggest problem was designing the interface that the user would actually see. But the tools we're using to create it aren't terrific, and also just thinking of all the different things the user wrote on to do, besides just setting the temperature or number of particles in the box and so on. And do they have a function so they can run several simulations one after the other, and stuff like that. So,
well, one of the biggest problems I had was actually implementing the code. We're just, like it's a lot of code, and we had to distribute it, and just getting all the code to work together. But also a lot of graphical issues, like working with MATLAB, which is the language we're using. It has some really great tools to graph things, but they take a little time to learn. So that was my biggest challenge, probably.
I think one of the biggest challenges for me was actually designing this and putting the numbers together so that it actually goes along with what would actually happen. There's lots of different things in physics lots of different variables that go into this, and getting all those numbers very accurate is very difficult.
Well, I've learned a new programming language, and that's always valuable. Had a good experience just working on a big project with other people, because at school most of the programming projects we did were just one person.
Well, I would say that the biggest way I've learned is probably, in team programming, but also just sort of working, organizing a large project and working out what some people are way better at other things than others, and just working on that and bringing all the stuff together into one big project is really you can't really learn it unless you do it, and this is one of my first times doing it. So.
Well, one of my favorite parts of this program has just been the time I get to spend with all these other people. There's 20 other kids here that have the same passion for computers and programming that I do, and just being able to spend 2 weeks with them has just been a great experience.
I would have to say my favorite part of the program would be just being able to work with 20 people who share my talents and interests in computers and programming, and also in science, and also bringing my interest in programming together with my interest in science to do something that's really real world, that applies.
My favorite part would be the fact that we're working with kids from all over the state, so it's really neat to see all these different people who all like computers all clustered into one area. I don't see that very often.